Good morning, everyone. It is indeed my pleasure to speak to you again. And this is my 17th year, so I'm very, very proud to be able to come every year. And I guess the most important business of the day is for me to claim that all views that I express are strictly of my own. And I come here as a private citizen and this so-called independent scientist. It's obvious that from the title, I'm trying to get more of you to come. So I'm trying to make it a little bit more exciting. So every year coming to DDP is like trying to put out the best that I know, and perhaps something that I just learned a few months ago, so please pardon me. For those who may not be familiar with the word picosecond, let me explain that picosecond just means 10 to the minus 12 seconds, so it's very, very short time. But we are in the regime of femtosecond, which is 10 to the minus 15, so we're about 1,000 times better now, so we are able to really study phenomenon like that, like collision between CO2 molecule, which happened in the order of several picoseconds. So we are able to study those things scientifically, of course. This talk will cover a lot of material, so please hang on and put on your seatbelt. I cannot buy any insurance, but here's what it is. But let me start with the first slide. It's a bit philosophical because after all this year, I finally concluded that the problem with the religion of CO2 is essentially this problem, what I call scientism, which is essentially all these cries and all these pretensions of science, but actually not actually doing any science at all, which is really the trouble that is causing all this problem that we have. Of course, by no means limited to only climate science area. This is the stuff that I really think that we should destroy at all costs, and I'm going to really do all my best during this talk to really cure the form of scientism that is prevailing in our culture and in fact in our scientific sphere today, which is really very, very dangerous, and in fact really, really will be very harmful if we don't work a little bit harder. Let not names name. If any of you who wants to read what I think about Bill 9, please ask me. I've written an op-ed, I guess 2 months ago on this, on how Bill 9 has been really not only not know his science, I mean this guy is manipulating science. So if you, like my son for example, will refuse to watch Bill 9's video now. So probably I'm not trying to influence them. I tell them he doesn't make sense. This guy lies basically all the time, which is really bad for youngsters. You know, youngster couldn't tell the liar from a person who really wants to tell the truth. In any case, let me get started. I'm trying to purvey a more positive message, of course. Science will be here forever in that sense. But we do have young people like this who are beginning to realize, for example, this fellow, William A. Wilson, I mean, he doesn't have a job as a scientist, but he knows enough about the problem in science that he writes a very beautiful essay who can say something that is so important in my view that I really like what he has to say. Because the greatest fans of science, he said, greatest friends of the cult of science are the worst enemy of science actual practice. So we really got to separate scientism from the real science, which is really the issues that is really caught us many, many times over. So let's start with our favorite movie star.
Here's what I think is a better explanation.
This is on explaining global warming.
Global warming, or none like it hot. You're probably wondering why your ice cream went away. Well, Susie, the culprit isn't foreigners, it's global warming.
Global wobble?
Yeah.
Okay. Well, Al Gore is actually telling you, and in fact he still believes that, this global warming can melt ice cream, which is unbelievable. So I would just say no more dessert for Al Gore. So now, let's see. It's very hot here. The Viennese fear that they will soon be unable to eat ice cream, and they have been a little cold last winter, and ice are being scarce. So who actually says this and when? So let's have a Victory Symphony, the first Victory Symphony at DDP. Let it not be the last, of course. Well, it's obviously those statements come from Mr. Beethoven himself. And it was stated around 1794, the summer of 1794, in a letter that he wrote to Mr. Simrock, which, by the way, he's also asking for a wife so that he could actually stay permanently in Bonn. Anyway, he ended up staying in Vienna, as we all know. History will have it that way. It's true, actually. If you check the reality of what is known, 1794, around that year, was quite a bit warm, actually. And at the bottom, or the top of the curve, I'm showing the temperature, I guess the nearest station you can find for Vienna. And then the bottom one, I show you the sunspot numbers. Basically sunspot solar activity. It shows that around that time, indeed, that the sun was perhaps a little brighter, so therefore, maybe it has something to do with the sun. So poor Al Gore, indeed, still trying to melt the ice cap by himself, which is very unfortunate, because this is the kind of scientism that is very, very dangerous, and he doesn't seem to have any ability to feel any remorse or ability to say sorry or he's wrong about this. So every time I think about Al Gore, it just remind me of this particular picture. I don't know if any of you know what this is, but I guess we can save that for wine and beer conversation later. In fact, this is very interesting scientifically. It's about horizontal gene transfer. I put up now a picture of the moon because people say that this stuff about global warming is like, people believe of landing on the moon is actually fake on somewhere in Arizona desert that people filmed this. This is a picture taken by our Apollo friends, of course, and it really shows is that. And the first thing I want to ask is that, now that by all the facts that we know so far, will Al Gore ever apologize? Because on the issue of rocketry, ability to travel, send a rocket to the moon, I mean, even New York Times has issued their correction. They corrected on July 17, the day before the flight actually was successful, Apollo 11 launch. I mean, they were using all this usual scientism language about Mr. Robert Goddard, the professor who invented this rocketry, have to go to take some high school classes, and he doesn't understand anything. That's basically the strategy. It appears to be the same. I mean, how many years over? It's always the same. So now the Times has actually issued their correction, an apology. I hope Al Gore will do that someday. This is just a modern version because we sent another unmanned spacecraft taking a view of the Earth. I mean, this is the latest lunar reconnaissance satellites that actually take a very nice view of the Earth also coming from the moon itself. So man landing or ability for man to go to the moon is actually real. It's a scientific achievement. So I guess for Al Gore to apologize, we really have to have some people landed on the sun before he will do that. Now let me start. Since we have opportunities while we are talking about ice cream, I'll start with this fellow that most of you may not know him. He's a geologist. He's actually come from Europe. His name is Francois Mathis. I mean, the geologists would know him. He essentially are the father of glaciology, in my view, in America. He studied glaciers in and out, especially on the Western Sierra. But for this particular slide, I simply want to point out about this origin of the term Little Ice Age, which actually has been widely spread in all the textbook and all these popular books that says that the credit should be given to Francois Mathis. Unfortunately, this is what another example of scientism, the best example of that is that all of these people actually never read those papers. They cited a paper in 1939 where Francois Mathis used the term Little Ice Age, but they didn't want to read the whole of the picture, which actually I went through the process of reading because I don't trust those guys. It appears that, you see, the term Little Ice Age, as credited by Francois Mathis, is a clever journalist. It's not him. So this is the kind of scientism that's a bit funny. When this expert of this and that simply didn't even study their own original document. Now we're talking about glaciers. This is an example of Agassiz glaciers. Remember, when Francois Mathis is studying this, is in the 1940s, right? Beginning of World War II. I mean, he's actually pointing about these glaciers in the Glacier National Park that says that if the warm continue, we all know that there was very warm period from 1920s to 1930s that are extremely warm, that large part of the glaciers actually melted away. And in fact, he says that if this trend continue, it will cease to exist in only a very few years, okay? It turns out that this is the kind of behavior that we should study. What happened actually? If you pointed out a picture from 1913 to 2005, you can see, yeah, there's a lot of snow, a lot of ice in 1913, and 2005 is clear up. But what you really need to know is that this glacier is a very dynamic entity. It's a bit like the whole climate. You just cannot look at one point and decide that this is it. This is the answer to it. You have to find something in between, like 1943, you will see. I mean, there is really not much difference between 1943 to 2005, isn't it? The glacier really ain't going away exactly, right? So this is the kind of scientism that is very, very dangerous, and one has to study it more carefully. For another example of a warning of how glaciers will melt away and there will be no more water supply for the people who depends on the glacier as a source of water, I mean, you just have to, please don't read this quote, of course, but the whole purpose is to say that there have been predicted long ago, at least when it was warm, that all these glaciers, if the warming trend continue, it will do that. This is not much science to it, that the glacier will cease to exist in 50 years. So now I want to point out a specific example of a glacier, the Grinnell Glaciers in Glacier National Park. The typical example is to show you a picture like this. 1910, whoa, a lot of snow. 1998, whoa, there's no snow, right? Okay, nice, very nice, but what happened in between? I need to know that. Actually, it turns out that I worked very hard. This project, actually, I studied about 15 years ago for my own satisfaction. This is what I found. And I never talk about it anywhere, by the way, because no chance to talk about this. Nobody wants to hear. The first thing you do is that you check what the geologists during those times says. This is from Gibson and Dyson, 1939. They actually already pointed out that it was very, very warm from the year 1935 to 1938 at that time, where the Grinnell Glaciers actually has reduced to about half of its size from 1900. Guys, I hope you all understand that CO2 level was very, very small from 1900 to 1940. It changes by no more than, I guess, 10 parts per million or something, very small, right? So CO2 has nothing to do with it. This is purely a natural phenomenon that has been known for a long time. So what are you going to do about it, right? You're going to save the glacier by reducing CO2? I mean, that doesn't seem to be a very good proposition. Even my son would know that. So if you look at the summer temperature record around that area and compare with the glaciers, which is those two lines that I pointed out, Grinnell and Spirit Glacier, they are decreasing in size. But the largest decrease happened during the very warm spike that is known from 1910 to 1930s, as you can see. It jumped by almost 2 degrees Celsius or 4 degrees Fahrenheit or so, right? And then ever since then, it just keeps fluctuating on and off. This is what climate does naturally, okay? With or without human, actually. And this is my actually project long ago that I checked this out. I keep finding look for any old photos that can tell you this. You can look from 1911, and then by 1935, indeed, the upper branch and the lower branch of the glacier has been broken in two. Okay? That shows you that the drastic change has occurred much, much early on, where CO2 could not possibly do anything about it. Okay? It was not responsible for it. There's no way. And then these are all the intermediate picture in between where I can able to find you 37, 58, 65, and 2005, roughly around summertime, of course. That's when you want to see whether there's any drastic melting of the glacier size. Because ultimately, it is the summer season melting that's going to determine the overall size of the glacier's mass for this kind of region. Okay? I couldn't find anything that convinced me to be really scared about glaciers going away anytime soon. So indeed, the question that I want to ask is, how is the world weather and climate trending for the past 2 decades or so? Did everything go according to the CO2 religion? Actually, I hope you understand, I mean CO2 is religion in the sense that you cannot test this idea at all. Well, the first thing we all know, this DDP crowd audience obviously know this, that for the last 18 to about 20 years or so, the global temperature doesn't appear to warm at all. The most recent spike during the the November to 2015 to 2016 or January, it's very warm. That's true. There's a warm spike, but those are phenomena caused by El Nino. And we couldn't even be sure that El Nino even have anything to do with CO2. So a lot of this phenomenon, it's really a very interesting case of scientism where everybody just use this pseudo evidence to try to claim that it is carbon man-made global warming that is causing all this phenomenon. But the fact is, we really don't have a case at all. In fact, the most latest, what I call measurement-based sort of checking of how the Earth system is changing or not changing is actually achieved by this group of scientists from Big Bear Solar Observatory in California, and they are actually based in New Jersey. And these are some of my friends from solar physics. The leader is actually Philip Goody, and they've been making those kind of measurement of the reflectance of the Earth light looking at the moon. So you are basically look at the Earth shining to the moon and then measure how much that area has been changing. Essentially, you are measuring the planetary albedo, which means how much the sunlight gets reflected from the Earth. So they've been carefully monitoring this since 1998 until the data lasted around December 2014. Does anybody see any trend? I mean, it's nothing, basically nothing. I don't know what else you want to do about this. So the case for CO2, carbon dioxide causing global warming or major changes in the planetary energy balance, for example, that's the basic claim, right? It's basically none. You can find it. If you can find it in the measurement, I'm sorry, you got to rest it, okay? Those guys, unfortunately, will keep going and going and going. That's why even Joe Bass doesn't want to have any more conference, because it's crazy. I hope you will have one or two later, of course, if the money is available. I mean, getting funding is crazy. It's too difficult. But anyway, that's the conclusion of this recent paper by this group of solar physicists from led by Enrique Pale and Phil Goody, of course. And they just couldn't find anything. Of course, it takes them about 3-4 years to write this paper because it's politically incorrect. So I guess nothing much but to remind everyone what Professor Albert Einstein has to say about this sort of thing. It is indeed no amount of experimentation can ever prove a theory right. A single experiment really can prove a theory wrong, which is really a case that is very, very strong for this what you call rising atmospheric global warming case, okay? This is how bad it is now, actually. I want to show you now some social phenomenon. If I were to try to look for a Google search for iPhone and climate change, climate change is actually the blue line, of course. The iPhone numbers is quite large, actually, substantially orders of magnitude, at least 1,000 or 10,000 times more searches than climate change, okay? This is actually over a very long period. I couldn't read the stuff, but it's over 3-4 years, last 3-4 years. And even that, when I try to search for climate change versus the search word Segway, by the way, before this, I didn't know what a Segway is, so I have to make this cartoon, like in Inspector Clouseau, what he says. Segway is actually this machine that a lot of people are using now at the airport and all that. I mean, if you look at the search term, I mean, Segway is actually not that bad compared to global warming. In fact, during 2015 or so, you can see, during that period, I mean, Segway really during 2015 or so is actually the search term is far, far more bigger than even climate change. It shows you that the popular people actually have no interest at all on this topic of climate change, except for Al Gore and his own paid audience, actually. In China, by the way, for all the places. And then this is the punchline. I don't know if any of you seen this news that I just looked up before I came here, July 7. That if you look at, y'all know that December 2013 or November, they have this big Paris Agreement meeting, the COP meeting, the so-called Convention on Climate Change meeting. And Heartland Institute did send some of us there. And believe me, it's not our effects, but you can see how many countries now. You have 197 countries who claim that they agree with this agreement, they have signed on to the agreement. But the bottom line is, a year later, almost a year later, if you ask how many countries has actually ratified, it's only 19 countries. That is 0.18% of the country actually that say this thing. This is maybe another form of their scientism. They really don't believe it. By the way, they're telling you that the next meeting is COP22 will be in Marrakesh. So the less people agree with this thing, the more conferences they're going to have. I really think that this idea is a train wreck. I mean, it's very, very sad. I don't know what else to do, actually. Please help me, God. Now, I tried to say that I will be positive, so we're trying to discuss, of course, what actually controls climate. This program this slide is actually trying to tell you that, you know, this climate system is truly complex, actually. This hasn't even included the things that I'm going to talk about later, which is going to bring you some headache, hopefully not too much. But the idea is that the system is full of all these different players, all this absorbed sunlight, you have outgoing radiation, you have latent heat flux, which just basically mean that the energy from condensation of water vapor. And then you have sensible and potential energy, you've got all these other factors. And of all that, I want to highlight CO2 in there, the tiny little CO2. For people to believe that a system of that much of an energy, you know, reservoir plus memory, actually. Memory is another really big problem in this whole formulation of the climate theory, which is very, very difficult. No one has succeeded so far, by the way. So to suggest that CO2 will be the dominant driving factors, I don't know. Even from logic, I think you find it very hard to accept. even from logical point of view. But the number just doesn't work out. Science is all about numbers. Has nothing to do with logic or emotion or this and that. It's about numbers. It never worked out, actually. It never worked out in the first place, which is really strange. So now I'm going to introduce Professor Will Happer's idea, actually. He, among all the physicists who really know very, very well about quantum mechanics, so they go and study exactly what is the carbon dioxide molecules. What is the property of it? It's a triatomic, right? We have carbon, we have oxygen and oxygen, right? And I want to point out that this work is really a beautiful work. He essentially show you that how the intrinsic property of the carbon dioxide molecule will be able to lead to a channel in which that because of the degree of freedom, many ways it can transfer and changes its form and its energy. I'll show the picture. That it actually was able to, it actually should be producing far less impact, boom, on the climate system than actually been used in the climate model or predicted by all these people who never work out the physics in the first place. Because these people are not physicists. They're just a machine actually, copying each other and they don't know what they're doing actually. Most of the time, to be not so kind actually, it's really almost all the time they don't know what they're talking about. So Professor Will Happer, which is of course a friend of Heartland Institute and most of us, he's a very, very good scientist and very calm person, and he's been studying this topic and looked back into this problem. So indeed, carbon dioxide, I told you, is a triatomic molecules, right? If you look in terms of the mode of the energy change, if you go only left or right, it really doesn't have enough a frequency to actually be related to greenhouse warming. If you just do a little bit of this rotation of that mode like that, you won't have anything. You just need the bending mode, the one that do like this, that actually will be able to produce this important greenhouse warming, which is true. CO2 is a greenhouse gas, okay? This is just a much more simpler way to say that the sun coming in, giving us all the energy, which is in the red, in the visible area, and then the earth emit energy in a cooler temperature. And CO2 passband happen to be somewhere in around that area, okay? 15 micron, which is in the blue area. And this is how Professor Will Happer has calculated and show you the number of ability of this carbon dioxide molecule able to change its basically phase, essentially, its behavior. And you can see this vertical stuff, which is essentially the pedestal. And the collision between two molecules of this CO2 is in the order of few picoseconds, as I told you. And it shows you how fast that from one moment to another, it can transfer a mode from the top to the bottom or go to the top again. It is how fast this thing can change, actually. And the change of this strength of this carbon dioxide, how it can change itself is of the order of 10 order of magnitude. That's 10 billion times. This is actually a beautiful set of calculation that he finally showed it. Actually, I had never seen it before because I'm not also a person that knows this particular area of physics, CO2 physics. And indeed even has something to do with the famous movie star, Hedy Lamarr, actually. And of course, this one I will give a little credit. By the way, the Beethoven stuff, I give credit to Benjamin because it was from doing homework with him that I found out about that quote. For this one, because Franklin is doing some piano now, and it turns out that Hedy Lamarr and one of his collaborators, George Antle, was able to patent this frequency hopping idea. It's essentially about sending a message. If you let the message be if you encrypt your message and the message been decoded by the German, then your torpedo will not be able to fire, it will destroy your stuff. They simply suggest the idea that instead of sending the message by using any serious code, you just pause the message by changing the frequency. And here they use the idea of piano. You have 88 frequency. They just do this hopping around. But think about the complexity of that CO2. We have thousands and thousands of these lines, okay? And this is the ability of how the CO2 molecule is so robust, it's able to change its mode from one way to another. Essentially, it's really, really hard to track down the precise mechanism of how this CO2 manifests itself. And this is just an example to show you of all the fine line by CO2, and the blue curve is actually showing you that the wings of this line is much, much broader than actually is predicted by what is actually available from quantum mechanics. And indeed, the quantification, the bottom line is that Professor Will Happer was able to show that because of this extra wing, instead of this pedestal that is actually much more narrow, the contribution of the carbon dioxide to the radiation forcing is essentially overestimated by a factor of 40%, which is really actually very, very large in this business. If anybody know anything about climate sensitivity issue, people say that if you warm the climate, you will get 2-3 degree or 2 to 3 degree. This factor itself immediately will reduce your factor by another 2, right? Another half. So this shows you that this is why we are not able to predict or able to detect this thing ever. And the actual measurement, again, show you that the wing is much more narrow than actually what is predicted using these line profile ideas. Okay? So let me move on. Essentially, this is trying to capture you that the idea of, by the way, it's not a hypothesis, this CO2 global warming, it's just an idea, it's not even an hypothesis, because it's not a scientific hypothesis. It's like a fish being trapped in this jellyfish is slowly dying. Hopefully it will eventually die. So let's hope the jellyfish will glue this whole thing and don't open itself. But still, CO2 can do something good for Al Gore, essentially. You can still increase the carbon dioxide concentration and do the experiment, and you can able to measure, let's say, the morphine production in wild poppy. It does increase, okay? But as I try to hint to my next slide, will be to try to tell you that this whole thing has nothing to do with emotion or Al Gore's mental health and so on and so forth. And it's actually about hypothesis making. This is the idea of multiple working hypotheses, which I really getting to be more and more serious as I grew older, perhaps, to try to be not so dogmatic in my own way, because ultimately we are the only person can fool ourselves is our own self, right? So we have to be really careful about things that we do and say. And this is idea of a geologist, Thomas Chamberlain. And by the way, he was a former president of University of Wisconsin. And then he retired to become just a professor at University of Chicago. That shows you that he doesn't like to do this bureaucracy paperwork. So yeah, indeed, one has to be aware that science versus scientism is really dominating this field. Essentially, you even have to answer a question like this: can accumulation of space dust increase the Earth's diameter so that it moves closer to the sun and contribute to global warming? That's basically the level of CO2 global warming idea, okay? But of course, I would say that for this particular idea, it's not very good at all. It won't even work, sorry. Well, it depends on what kind of dust. So yeah, still I want to answer the question, what is climate and what causes the climate to change? Remember, climate change on many time scale, okay? You have diurnal stuff, you have seasonal, you have annual, interannual variations, and then all the way to the ice ages, which is hundreds and thousands of years, and then to even millions of years, and then you got to talk about tectonic, all this continent built together. It's a very complex system. In fact, this is the problem. It's such a complex thing that actually there's not a single question. Please ask any question that you think you have. That in the area of climate science, because it's so immature, that we don't have any definitive answer one way or another in a lot of sense, okay? So, to study climate, here's what you require to understand. I highlight stuff that I'm going to talk about next. You need astronomy, you need solar physics, you need geology, you need to know a bit about geochronology, geochemistry, sedimentology, tectonic, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. And even more that I cannot list down here. I just simply copy what Ian Plimer has to say. Ian Plimer is a geologist from Australia, of course. So he say, please don't say that you want to study the climate by just studying the atmosphere, because everybody is just talking about the greenhouse effect of the CO2 impact on the atmosphere, infrared opacity, for example, you know, how much it regulates the infrared radiation. For that, to get into tectonic stuff, I like this quote very much, by the way, by the Alfred Wegener. We all know that he's the father of continental theory, right? Continental drift. He did indeed emphasize that you must, if you really want to understand all this phenomenon, you really need to understand most of the factors of all the Earth sciences. I'll give you a simple example. Why is the Earth rotation at 24 hours? That thing is not very well known, actually, not well answered. Actually, the resonant period should be about 21 hours, not 24 actually. Because the moon tide is about 10.2 hours, so the perfect one should be 21. Why are we at 24 hours? Do we know an answer to that? Not even close. Okay? There are many more things like this. Here, equator. The sun passes the equator twice, right? You have the radiation pass the equator twice. But if you look at the equator ocean temperature, why is it that it has only annual cycle? It doesn't have the semi-annual cycles. Okay? You think we know that? You ask the oceanographer, the world famous, whatever it is. We don't really know that well, okay? This is the kind of stuff that I continue to keep working, grinding it away, but I'm finally reaching to the point where I can report something that I feel happy about, which means it's going to last for a long time. So let's talk about this issue about solar, climatic, and tectonic and magmatic relationship. which is actually would be able to provide a very good way in which at least one of the first most promising way to explain the ice age cycle, for example, in relation to the solar orbit theory that I've been working on. So quickly, we're going to go over three points, and first one will be on this tidal stuff, but let's talk about where all this world ocean, mid-ocean ridges is, okay? These are very, very new area. In fact, everything under the ocean actually is not known at all, actually. You can see, let me see. Yeah, the red symbol are the one that has been measured, and then the yellow symbol are the one that actually we just interpolated. We haven't been able to sample or study anything underneath the ocean. This is around all the fault and all the ridges, where you basically have all this magma coming out and plume. You can have all these other activities. All these are related to volcano plus earthquake and all this other stuff. It's somewhat complicated, of course. I'm not at all an expert, but I'm just beginning to look into this to try to learn a little bit more what happened. So let me introduce you to the first thing that will be related to our discussion. It will be this so-called abyssal hills. Right? These are actually not hills. They're really quite large hills. Happen underneath the ocean. Okay? Happen along, and I'll show you the details. Well, it's also a main area, as you know. The reason for this importance is that this is basically a very important area for geothermal heat flux, which means something from the mantle and the crust are heating the ocean bottom, in fact, drive the ocean circulation and things like that, far more effectively than anything you can heat from the top, which is, let's say, the infrared back radiation. I mean, Fred Singer can tell you that you can't even see this within the skin layer of micrometer of this surface layer from heating from CO2 forcing. So these are the big giants that nobody wants to study. Simply, by the way, it's also because there's not much data, but we are making progress. There are works going on. So for the ocean ridges, you can see the blue is basically the shallow region, and then these are the top part, the green and the red part you can see from the cut cross section of the ocean ridges. One is in the southern Indian Ocean, one is the mid-Atlantic Ocean. Okay, you can see it has this stuff. In fact, it's quite high, the hill. Some of them is on the order of 1,000 meters, you can see. Some deep is up to even 2,000 meters. So these are very substantial kind of modulation underneath. Except now, what does this signals actually say? We need to know that. The first thing I want to talk to you about is basically tidal and sea level effects on volcanic and magmatic relationship. Actually, this is far more surprising than I can imagine, actually. I didn't even know that such a thing exists until I start digging up. So the idea here is essentially that if you have less ocean water and those ocean water go into the continent, then you are essentially unloading the load that you put on the ocean crust, right? The magma, this mid-ocean ridges, right? Then if this water go there, then the sea level drop, right? Remember, sea level of the ice ages, we are talking about 120 meters of the sea level in the ocean, which is really a lot. That's about 300-400 feet of water, okay, that being bring into the continent. So you really unloaded a lot, and so you lower the pressure on the mantle, then you can increase the eruption of these mid-ocean ridges around. And then in the process, of course, you emit all kinds of stuff, including CO2. So this is very interesting in that sense. The whole idea now about science, again, is rather than scientism, is that does this idea work out? So it turns out that this young scientist, by the way, now he moved to University of Connecticut, so he moved to University of Connecticut now, David Lund, has been studying this stuff very carefully, and he worked out the numbers, and it turns out that this number is very promising. First, we show you two graphs of the sea level changes. It's as I say, it dropped by about 120 meters. During ice ages, right, about 20,000 years ago, you can see, you have actually sea level drop by 120 meters, right? Okay, the sea level is very low. So the idea now, what happened during that time to this mid-ocean plume? Do we actually have numbers that can show that it's actually increasing around that time because you're reducing the load because all the ice are going into the land continent, right? Indeed, you are able to show that there are substantial increase during those two pulses when you have substantial land ice being accumulated, which means the sea level is really a serious factor in controlling how much these mid-ocean ridges are actually emitting or not emitting. And then this is measuring the chemical, like you can measure the iron or osmium or manganese and all this other stuff. These are all stuff that will be relevant to biology and all these other studies and geology. They indeed are able to show that this thing happened. As you have the ice ages, you actually are emitting more from those ocean plumes, from those magma plume, and you are able to show this phenomenon. And in fact, a few years later, they were able to measure the precise, this is a new paper just came out this year, showing you that they are able to show this effect indeed happen. Then I want to talk about something also exciting, which is something that I didn't expect to happen. Actually, it does, it's true. It's about seasonality of volcanic eruption and this mid-ocean ridges eruption. Does anybody know that actually the eruption of the volcano depend on the season? I didn't know this actually before this year. It turns out that this study has been conducted very carefully. But the idea here is essentially, if you're going from January to July, you are in a phase in which, let's go from July to January first. Okay? July from January, you are actually loading up the system. Okay? You're loading up the system from July to January simply because of the relative distance from Earth to the Sun, right? And then, of course, there's also the tidal effect. You have to remember that. And then, when it's during unloading phase, you will see that the possibility of more volcanic activity will be happening during that phase of unloading because the system is not being squeezed. So this paper actually is really mind-opening. It's done by David Powell from Cambridge. He was at Oxford before. And he was, with his group of students, they actually look at all the compilation of volcanic eruption ever, okay, from actually very large to very weak eruption. In fact, most of the volcanic activity happened from 0 to what they call the VEI index from 0 to 2. The large one happened at 5, 4. But let's not talk about the large eruption. If you look at those quiet and slow eruption, okay, it turns out that most of them have that seasonal dependence, which means you have much more eruption happen from November to about April and then much less during the summer month. Okay? It has that seasonality. I never know this statistic exists, which is really promising in that sense. I will show how it links to this ice ages problem in a minute. And again, this stuff also related to merely the sea level loading, but this is on seasonal level. The changes of sea level here is on the order of 10, 20 millimeter at most, right? 10 millimeter also. But you are able to see, depends on the year of course, but it doesn't matter. If you look at all the record from 1700 to 2000 or 1700 to 1900 or that kind of so forth, or the 1900 to 2000, you will see that during the November to April month, I mean, you have more activities, and then during because actually also related to the sea level. The sea level was low at that time. And then when the sea level is high, it's more pressure on the system, so you actually have less eruption. Okay? This is a very surprising fact that exists that I didn't know before, which shows you that something can link all the way from season to even ice age, because that's related to the large scale of the mass. Tiny changes from 10 millimeter of the sea level to 120 meter of the sea level. These are all connected. And where's the connection? The connection is related to Earth going around the sun. Okay? And here is finally the Tolstoy picture. In fact, I would say from all my checking, this person is probably related to the original Tolstoy. Her name is Maya Tolstoy. Maybe I pronounced it wrongly, but she's a geologist, and her father is also a very famous oceanographer who studied ocean acoustic, and she's at Columbia now. She actually formulated this theory. The paper took her from 2008 to 2015 or something to get published. Okay, take a long time because it's not a popular idea. But she's very persistent. She studied this phenomenon very carefully. So she produced this paper recently that actually show you that actually this idea of how you connect from season all the way to ice ages, which is to study the activity of the mid-ocean ridges eruption. Okay? So she calls it's a control of climate valve. It's not a climate knob. Okay? And she show you that this whole thing can happen on 100,000 years timescale. I'll show how. Okay, don't get confused by this chart. This is just a sample of showing you the actual detection of the mid-ocean ridges is very, very few because it's completely unsampled. This is the 9 events that we know so far. And then from the 9 events that have been detected by the time of 2015, she was able to show you that most of them happen from, like I say, January to about May month. Okay? And then most of them also happen during a time where the tide effect on the system, the moon and the earth tide, and the sun tide effect on the earth is actually the minimum, the nip tide stuff, where they are at a perpendicular angle. And then the timing of the eruption is shown at the red dot. This is very, very interesting statistics. She was able to demonstrate that. Then she went a step further. This is actually on every 2 weeks kind of time scale to 1 year. And she started to look into this mid-ocean ridges and the abyssal hill statistics. Okay? By the way, there are so many types, and she is actually focusing this phenomenon on the fast-spreading one. These all happen on the order of, if I can read it, is about 15 millimeter per year, and then the intermediate stuff, there are the slow stuff, okay, which means they happen on much, much slower time scale. These regions are spreading, and then they created this hill, right? And what she's doing is that she measured the distance between those abyssal hill to try to represent the rate in which that the ocean is undergoing this loading from the sea level changes of the ice ages. Those distances represent that. If you have the rate, you know the time. So she was able to produce this kind of statistics. Based on nine of this sample, nine cross-section, she was able to produce the bottom curve like this, which is how much the sea bottom, the barometry is changing. Like you say, it's on the order of 100 meters. She was able to show this from about 800,000 years ago to present. It's showing you up and down. And then at the top curve, you can see the carbon dioxide from the Antarctic Ice Core project. And then the top curve is to show you the role of the eccentricity, which is really is very, very important because the Earth's relative distance to the sun can provide you that effect that we're talking about that we see in volcanic activity and seismic activity. Okay? And again, it's the same picture, but this is finally cleaned up. He explained very well, especially why is it that the ice ages cycle, we don't see it very dominantly happen in, let's say, the precession cycle or the tilt angle cycle, which is 41,000 years or 23,000 years. We don't see that. It's filtered into 100,000 year time scale. This is partly because related to this phenomenon of the eccentricity, the shape of the Earth orbit around the sun. Okay? I really think that this idea is very, very promising. This is why it's independently is somewhat, okay, just to show you that, you see, if you use a time series detection technique, you will show that most of the period happened in about 100,000 years or so, okay, in all these three phenomena. Somehow they are related. This is somewhat related to some work, so I'm almost near the end. I want to report some of the work that I've been doing with these young colleagues from Argentina, who actually doesn't even have beef to eat because most of their country export the beef to foreign country to get the US dollar. And this is a very, very good scientist. I've been working with him for almost 4 or 5 years now, quietly, totally unfunded. If they want to put me in jail, so be it. I'm just going to keep working on this because it's very fun and very exciting. So we've been working on it, asking those simple questions. You know, how does the Earth rotation rate change? How does it change? Why does it change? Okay? So we actually went and for the first time, revisit all the old problem of how you calculate the orbital dynamics. Remember, you think it's simple, huh? Newton mechanics. It's really a difficult problem, actually. If you don't know how to do it, you got to do this right. You have to have the time coordinate system, everything correctly. By the way, a lot of this work contribution come from him. I just give a little bit insight from left and right, just check him and do things like that. But he's really a brilliant guy. We were able to put together the program. It was supposed to take 3 years, and he finished in 3 months. Okay, so we got it done. We're about writing a paper now. Hopefully they won't give me hell on this, but I'm going to publish it anyway. So this is just a way in which a fixed location from Earth, you can see this, how the sun is changing, right? I hope some of you know which one is summer, which one is winter, right? Yeah, the shorter one, I think, is, the higher one is summer, the bottom one is winter, right? The lower angle. So this is a very nice way to represent how the orbit of the Earth around the sun. And we make this calculation. I just want to show you some numbers from the 65-degree latitude north, because that region is really, really very important. I hope some of you can see, I blowed it up. This is by help of David Legage to show you that most of this 65-degree latitude north is actually mainly consists of land, okay? Which is why this region has always been a traditional value that why people use it, okay? Rather than, let's say, 50, for example. It will be too many ocean area, right? That's related to this ice age idea, right? And we calculated this stuff. I can only show you numbers for 2,000 years. This is showing you the incoming radiation modulated by the orbits that is changing, okay, plus the changes intrinsic to the sun. And I say that this particular number is a challenge for climate dynamics because it does show that at the so-called Maunder minimum period, from about 1600 to 1700 or so, you do have indeed the lowest solar radiation ever received for the last 2,000 years. And indeed, Mr. Francois Matthes has noted long ago that the French and the Swiss glacier were advancing very rapidly, especially during the period 1643 to 1644, okay, where the ice mass accumulated to the maximum size. And here's the picture to try to show you the French Alps. Just imagine the amount of ice is coming into this village. Those guys must be praying seriously, no? Or maybe they call Al Gore to do some work, to shine his, this torch. So yeah, it's probably related to the sun, as I can say. This is part of the work that's been ongoing for many, many years now. By now, I think I've done this work long enough. It's perhaps related to this period of activity is known as the Maunder minimum. Indeed, Maunder minimum period is a very interesting time. The top is, of course, the period of Maunder minimum from 1645 to 1720 or so, let's say. And then the bottom curve is to show you how the sun is doing regularly. So the sunspot appear on higher, let's say 35 to 40 degree latitude, and then systematically appear in lower altitude, and then they keep going like a butterfly wings. And then during the Maunder minimum period, in fact, it barely appear on the northern hemisphere at all during certain period, right, from about 1680 to 1700 or so, right? And then the pattern is a bit asymmetric. There's somehow nothing appear on the northern hemisphere, a little bit on the southern hemisphere, but they're very squeezed up, right? It happened at only 20 degrees. It usually appear at 30, 40 even, okay? So this is indeed a very unique time that I really think that it really shows up in the climatic record, not only, and then the sun stuff is really in correspondence. So I don't know what else to do if you keep claiming the sun could not affect the climate system. And this is just a little treat for some of you who love about sunspot. I want to show you this nice animation of somebody just put together all the Galileo observation ever been done. So he make all these photographs, and we thank Galileo for giving information like that, so we know what the sun is actually doing around that time. This is the kind of scientific work that require very, very serious dedication to be able to do this work. And I'm almost done now. I'm really done now, actually. I simply wanted to celebrate life by saying that, yes, we know something, but we don't know a whole lot about the earth sciences and how it behaves itself. So, indeed, a responsibility of a good scientist will be really to do what Professor Richard Feynman, of course, I hope some of you know who Richard Feynman is to try to say that we should really be not afraid to say that we don't know. We should really, in fact, that is a source of motivation for me to learn more, because you simply don't know, actually. How dare you go and talk to somebody when you don't even know what everything, most of the stuff that you're talking about, right? So we really should really build this new culture this basically traditional culture of science, that we should not really try to promote more discussion, open discussion, objective discussion of science, rather than trying to silence people. Like they're trying to use the Attorney General to keep us quiet. Come on, please, that's very childish. You can put one of me in jail. You cannot put the whole room here, right? I hope some of you are willing to go to jail with me. Are you? Okay, I'm done. Thank you. If we have time, maybe questions. Do we have time? Okay.
Well, I'll have the temerity to ask the question. I asked Richard Lindzen a question about the work of Gerald Rowe and the Milankovitch cycles. Do you think that this is going to replace his answer as the causes of the glacial and interglacial periods? In other words, are Milankovitch effects?
It doesn't replace anything. It's just the work by Professor Richard Lindzen's student, former student, Gerard Rowe is, put it this way. They are doing a bit of a cartoonish explanation of things, taking a derivative of a curve. It doesn't mean anything. It's not a scientific work. It's not real work in that sense. It's just simply to say it's adequate to explain something. But, okay, what do I know next? I want the real answer. The real answer is to study the whole thing system. Because they are ignoring factors like magmatic eruption, right? They're ignoring basically a lot more complicated about this Sun-Earth orbit. This is why I dare to stand in front to tell you that actually we're providing the new integration. Unfortunately, I can do the 100,000 years here. It's too difficult. Because you really need to worry about because those also depends on the ice. How much ice you have in certain, how the distribution of ice will change the moment of inertia and how the rotation Earth or the rate is changing. So your definition of time is not so accurate. There are many, many more layers of problem that I think if you just by hand waving, of course you can explain a lot of things, but it doesn't do much.
Okay, so I take that as it's in some jeopardy in your mind as being a substantial explanation of the glacial interglacial periods.
Right.
And the other comment or observation is I think that Rowe made estimates of radiative forcing from the change just in insolation and the accumulation of ice, 50, 60, 80 watts per meter squared, maybe 100 watts per meter squared where, of course, the IPCC, 1 to 2 watts per meter squared. Are you doing that sort of watts per meter squared change in radiative forcing as part of this project?
Yeah, that's the whole idea. But the point is that you don't want to talk about those kind of numbers. So it all depends on time scale, depends on how persistent the forcing is, what kind of forcing is that. And then it also depends on, the problem is that there's a lot of nonlinear knob in this system. Every single one of them, like vegetation actually is one good example. Or actually just the shallow water, ocean, the mixed layer, it really varies. A lot of this system, and you really need to know what level of question you are asking. In fact, I'm working even on the level of diurnal changes, which is really interesting. Do you guys know that in the Western Pacific, the Wampu area, the diurnal changes of the mixed layer can change by substantial, almost all the order of 5 meters, okay? Day overnight. I mean, that's interesting. And then if you keep having that nonlinear, imagine you have that low short time scale, and then what happened in a long time scale? Does it change in a 50 to 100 year time scale? You know, you want to know those things. To be sure something happens, something doesn't happen.
So you're going to deliver us this groundbreaking theory of the causes of the ice age?
I did tell the people that I want to retire because it's a really serious problem. I got so much headache from workplace that I almost want to do something else. No question? Thank you. By the way, this is only a warm-up act for my friend Professor David Luggett, who is coming up next.